Sharing starting. Okay, it's all yours.
Okay. Yeah, I don't know if you can see this sketch. It's kind of light colored print, but it's the what you want in the Arduino IDE is the standard Firmata Wi-Fi sketch. And if it's a if you got a fairly late version of the Arduino IDE, I've got 1.6.8, and then you get the in the board manager.
Mm-hmm.
You want to make sure you have these ESP8266 boards loaded in the board manager.
Okay.
So once you do that, it's just a matter of downloading the sketch, and it's all set to work with Johnny 5 over Wi-Fi.
Okay.
There's one thing to look for. Is when the board starts up. If you're using DHCP, you'll have to watch the board start up in the serial monitor so you can grab the IP address.
Okay.
Because it's liable to change if it's DHCP. That just happened to me today. That I fired the board up, the address had changed, and it threw me off a little bit. But and also you have to turn on the debugging in this sketch. There's one little line in here you have to uncomment, and I'll show that in a minute of the lines you have to change to make that work. Otherwise, you'll never know what IP address got assigned.
I see.
And then going to Johnny 5. There is one library you have to load up. And this is my little Johnny 5 program here. All this does is it blinks an LED and it reads an analog pot value. So the trick is to have this EtherPort client library, and that makes the Ethernet port look just like a serial port as far as Johnny 5 is concerned.
I see.
So yeah. So a couple of values you have to plug in: the IP address and the port. You can actually set the port in that Firmata sketch to what you want it to be. The default is 3030. And then there's 3 lines you have to change in the Firmata sketch to get this to work. Where it says define serial debug, you want to uncomment that one so you can see what it's doing when it starts up. And then you also have to put in there's a line in the wifiConfig.h where you set your Wi-Fi SSID, and then another line to set your Wi-Fi passphrase.
Okay.
So those 3 things, and then all the sketch does it connects, it blinks an LED, and then it reads an analog value from the analog pin. So once you've got that new board with the EtherPort client object, and then all I did here, the rest of it's just the straight up Johnny 5 stuff like you've seen a million times. Blink an LED, and then I defined a sensor and made it, make it read the sensor. You can see down there at the bottom my values are changing when I turn the pot.
I see. Okay.
So I got that, and that's about as far as I got with it. I was just happy that I got to make it work. Took me
That's pretty cool. What are you doing Sunday?
Wife's birthday weekend. Okay. I would love to make it if I could, but I'm kind of committed on that one. So anyhow, my next step with this is I've got some DC motors ordered and a little robot car chassis, and I'm going to try to work toward wireless, at least a wireless robot car platform. Yeah, just where I can steer it from the computer console with the arrow keys, and drive the motors. So that's step number 2.
Yeah, it'll be interesting to see how responsive it is.
Yeah. I mean, there's a lot of things that go with that. There's functions in Johnny 5 where you can control like this animation object, right? I was reading about this using the animation object with servos. And you can do all sorts of tricks to make it be, like smooth transitions, from one position to another, and not drive them like at full speed back and forth and have all kind of jerky stuff. and the animation object's got all this stuff built in where you can do this. It's called an easing function.
Yeah, the easing.
And you can use that easing function to make smooth turns and speed ups and slowdowns and stops. And the other thing I found to do with that, and this is another book. This book is Learning JavaScript Robotics.
Okay.
And that it's gosh, I don't even know who the author is. I just found it like a couple of days ago. But
can you post that link to the Meetup group page?
Yes.
That'd be great.
Yeah, and most of this book is like, it's really basic stuff. It's the same stuff that's in the, like in the Johnny 5 Inventors Kit.
Mm-hmm.
But if you get on down into this chapter 7 where it does advanced movement with the animation library, and explains all this stuff about how to use the easing function, how to do the animation object, and we were talking about this last week, the keyframes, and how to set those up.
Yes.
The example she gives here is with servos. She does one servo and then she does an array of servos.
Okay.
And that's pretty cool. She sets up this animation object where all 3 servos are doing different things, all synchronized.
Got you. Uh-huh.
Yeah. Yeah. So let me see if I can find that. That's all the one servo stuff there. Yeah, see, this talks about the keyframe object and goes in pretty good detail of, all the options you can apply to it. Most of these are, these 2 are, basically for servos, but easing you can apply it to a DC motor or an LED or just about anything, I believe. And this was pretty cool. Instead of giving it an absolute position, if you just give it a number, it goes in relative steps, right? Like that one. That one is saying like from there to there. That's saying going minus 45 degrees from where I was before.
I see.
Yeah. I was trying to find that one about the. Okay, here we go. Multiple servos in one segment. And what you do, the cue points, that's kind of still the same. That's just chopping up your time values into, beginning, halfway, and then at the end. And then your keyframes, you pass it like an array of objects. Like that first one would be the first array, the first servo, and that second one would be the second servo, up to ever how many you have.
Mm-hmm.
So you can control each one independently. So that's pretty much it. The rest of it just she walks through, actually doing a little demo here with it. And you plug all this stuff into the animation object. So you get that as far as I can determine, that's how you tie your keyframes together with whatever kind of device you're controlling. That could be servo or motor or LED, whichever was appropriate to your project. You can queue up multiple animations to play like one after the other.
Mm-hmm.
This thing it kind of makes it work like an MP3 player. You can skip to the next animation, go back to the previous, end it, play it back faster or slower. All these,
So I see where you can you can determine some basic, like let's say you built a finger that was, finger being controlled by a couple of servos, and you could have some or say you had a hand and there was different servos controlling it, you could have some basic motions as animation sequences kind of pre-stored in memory that you can call upon rather than trying to figure them out each time.
Yeah, exactly. That's what I was getting out of it too. You know, it's like you could have like a library of these things, you know, and then build it up into bigger sequences. Like if it was a hand, I mean, you could have a basic, like, you know, grasp and let go, and, you know, point the index finger, whatever it was. Yeah.
You could have certain keyframes for going to different, you know, if you're, you know, doing sign language.
Yeah, good example. So, yeah, I don't know. I mean, this part, I was starting to really like what they're doing here. I was thinking about how hard this would be if you were programming it and if you were doing it in C.
Oh yeah, you would be, yeah.
You'd have a long way to go.
Well, you'd be doing a lot of coding just to build the libraries up. You'd have a lot of the classes would be pretty complicated.
Yeah. This is really giving some high level stuff to work with here. And the other thing that I thought would be fun to use this for would be something like model trains.
Okay.
Yeah. I haven't had a model train set since I was about 12 years old, but I could just imagine, you know, having a speed. You could have a speed controlled engine and work all the switches and, you know, lights and everything in an animation sequence. That would be pretty cool.
Yeah, I'm curious on that ESP8266. Is there a way you can make it always grab the same IP address?
Yeah, you can. You can feed it a fixed IP. And it's in, and I think all you have to do is like uncomment that part of it. Let me see if I can find that. It's in this header file.
Okay.
Yeah, right here. Which is step 4.
Okay.
If you have a static IP, you uncomment this stuff.
Super.
That's what I need to do with mine because it's handing me a different address every time.
Yeah, and where did you get your ESP8266 at?
I got that from a Chinese place called Banggood. I can put that in the chat too, or we don't have a chat. I'll post it to the website.
Okay, is that how much? Aren't they like $4 or very cheap?
Yeah, well, I think I gave like $6 for this one, but it's built just like an Arduino. It's the same footprint as an Uno.
Oh,
and
okay.
More or less the same pinout. Let me see if I can show this on the camera because this is really kind of cool.
Oops, you don't want to do that.
Yeah, how do I undo this? Let's see.
I've done that before.
Yeah.
Okay, so your camera.
Okay, I'll try to show this board. See, it's just it you know, like Arduino shields would fit right on it.
Oh wow, yeah, that's cool. And that was only $6.
Yeah, $6. I mean, it's just for the board. It didn't come with the breadboard and the base and all that, but just the you know. So you know, and you can just use an Arduino IDE. You know, if you get the board in the board manager, then you can pretty much treat it just like you would any other Arduino board. The only thing to watch out for is it's 3.3 volt logic.
Yeah.
So you gotta be careful for that. And there's only one analog in. So that was to me a little bit lacking on that.
Mm-hmm.
Of course, you could expand that in a number of different ways, but other than that, it's got plenty of GPIO pins and PWM. So no, it's pretty easy to set up, you know, and just treat it like I did my Uno more or less.
Yeah, and it's low cost too. I like that.
Yeah.
And even if we went with Adafruit, they sell some. The thing I like about the little Adafruit feather board, even though it's a little more expensive, is it's got the built-in power regulator. so you can add a battery into it pretty easily.
Yeah.
But that's I already have a couple of those, which that could be I could use those.
Yeah. I mean, you could take that sketch I showed, and it would probably just work, verbatim, because that the board. I mean, the chip in those Adafruit ones, I think, is like one revision different from the one in this Banggood board that I have. This one's it's like a ESP 13, and the one in the Adafruit is like an ESP 12, and they're basically the same. I think the pin out's exactly the same.
I like that.
But yeah, I'm kind of torn. I like to support the companies like Adafruit and SparkFun and that, but also I'm a cheapskate and I'm on a budget. So
yeah, I hear you.
I'm forever looking at these, at these Chinese, low budget places, and they got some pretty good deals.
Yeah, they do. Yeah, I'm trying to figure out on this. I'm thinking about, like if I was doing well, I was thinking, I like the way the Tesla has the basically the Linux on board to where it can be standalone, but it's pretty costly doing that. So I guess it just depends on what your exact needs are for the project you're working with. As just another thing I thought was would be fun to do is the particle photon, but that's like a $20 board.
Yeah, and that's what's kept me from buying one. I'm limited on how much I can spend on this per month, and what I've done is just like my motors and robot car chassis. I found the motors and the little chassis and the wheels. It was $11 and some change, almost $12, plus shipping. Right. And that same part, if you bought it from one of the, part houses in the United States, it'd be like $25.
Okay. We'll be really curious to see how well that Wi-Fi will work for controlling the robot, because essentially you could have all the brains running on the computer, and the robot could be, moving around the house and so forth, and you could be, reading back the values on what it's, if it's detecting, what it's detecting in its environment.
Yeah, exactly. The next thing I want to do, I mean, long range, I want to build a rover that could go outside, like go across, I don't know, down a unpaved road, or across grass or something like that.
Yeah, you probably want to get cool. Well, that about covers that, you think?
Yeah, I think so. Yeah, the only other thing I wanted to mention on that is like the motor controller boards, the H bridge.
Yeah,
it's another price difference. If you go to SparkFun, it was like $12, and then I found one for $3. Basically the same circuitry. But the problem that I run to, there's either no or low documentation on these things.
Yeah.
So you get them, and then you end up spending hours trying to track down something on the internet that that's where somebody has used it, or a diagram of it.
Mm-hmm.
So yeah, that's pretty much what I have. So.
And we think you're going to get the parts for those. Do you have an idea?
I've got my. It should be within the next 10 to 14 days. Like I ordered some, Mouser Electronics.
Yeah,
Mouser's a pretty good place, and they're headquartered in Fort Worth, I think.
Yeah,
but I ordered some chips from them, and I got it it was like 2 days, and they were here. But the Chinese stuff, their chip shipping, I got the lowest cost shipping, and it was like 14 days. So it's going to be, probably be a few more days before I get it.
Okay. Well, great. Well, and Till then, you're going to leave these links on the Meetup page.
Yeah. I'll post that, and if I can figure out a way to, is there any way to like upload a file? Because I got this, I got this code. The last time I tried to paste it into the comments, it like unformatted the code.
Let's do this. Maybe you could email that to me, and I could post it up into CodeBender, and I can just maybe put together a web page or present it in a web page and stick it on the website.
Okay, let's do that.
Send me an email and just kind of write up a short thing, and then I'll convert it over to a web page and put it up, on the HackerSpaceTech.com, and then link to it from the Meetup. And that way, the code will be nicely formatted, and if they want to, they can copy it directly out of CodeBender into their own account or download it to their board. But of course, actually, the CodeBender I don't think supports the ES28266, but the code can still be put there, and they can copy it from there or study it.
Yeah, copy it down local, and then they use their own local IDE to do it.
Exactly. Super.